This is not just a random photo. This is a special photo thousands of scientists around the world were waiting for. The reason? It's the first photo of the James Webb Space Telescope. The James Webb Space Telescope is the biggest telescope in the space, and now it's 1.5 million kilometers off from the Earth. The James Webb Space Telescope is worth $10 billion. It seems to be nothing special with this photo, but it has an impact of the sense like the first step on the moon. So what's special about it? And what does it show? The photo depicts a star from the Milky Way galaxy. The James Webb Space Telescope has been designed to be an orbiting observatory that will peer back to the first galaxies of the early universe and should provide unprecedented views of cosmic phenomena. It was just set up, but the team has already taken its first photo with it. This intricate design is not only fully operational, it has performed better than we could have hoped for with impressive results. We all know how important the question of life elsewhere in the universe is. Putting an end to this burning dispute would be no small feat. And considering it has everything needed to detect extraterrestrial life, many are excited by what James Webb can offer. Several thousand scientists from around the world were employed on the James Webb Space Telescope and $10 billion spent. However, what tasks do they expect it to solve? After all, the famous Large Hadron Collider, which is almost 27 kilometers long, took about 10 years and less than $9.8 billion to be created. And it still made it possible to discover the famous God particle, the Higgs boson. There are thousands of articles and hundreds of videos about this new space telescope. So many of you probably know that it operates in the infrared range and is 100 times more sensitive than the famous Hubble Space Telescope. To build such a sensitive device, it was necessary to create most complicated folding mirror consisting of 18 hexagonal segments. The launch took place on December 25, 2021. It was delayed by a week due to additional technical checks and bad weather. And then, when the powerful Ariane 5 disappeared behind the clouds, thousands of people silently prayed. The telescope as high as a 3-story building and an area of a parking lot for 20 cars had to be brought into a working condition in space without human participation. And not only did it have to deploy the sun shield and mirror, but also adjust it so that each of the 18 segments took a strictly defined position with an accuracy of several nanometers. This is thousands of times thinner than a human hair or billionths of a meter. An extremely complicated task was accomplished. The first good news came in February. The telescope systems transitioned from transit to working mode. All 90 cables and 107 launching devices worked flawlessly. Soon, the first photo taken by the telescope flew around the world. It depicted the unremarkable lonely star HD 84406 from the constellation Ursa Major. Even though this celestial body was only picked to test the telescope's performance, at the time, people discussed it more than any other space object. But why this star? Well, it sits far enough from the other stars in the sky. This way, it was much easier to assess the telescope's performance as HD 84406 was the only one in the frame. After assembling the James Webb Space Telescope, the project team needed to confirm several things. They had to make sure that the near-infrared camera NIRCam was ready to collect light from celestial objects and then identify starlight from the same star in each of the 18 primary mirror segments. The result is a mosaic of images of 18 randomly arranged points of starlight. The device started to capture images on February 2nd, and 1,560 of them were generated using 10 NIRCam detectors. The whole process took almost 25 hours and resulted in 54 gigabytes of raw data. These images were then stitched together to create a single, large mosaic that captured the signature of each primary mirror segment in one frame consisting of over 2 billion pixels. Specialists then began to adjust the segments of the mirror to obtain characteristics laid down by the telescope's developers. After a month and a half of tiring work, NASA announced that the precise mirror alignment phase was completed, but they still weren't done with the adjustments. This stage, like the previous one, was also marked by a space image. This time, it was a star that doesn't have a name but a catalog number TWOMAS J175554042 plus 6551277 only. Aside from the fact that it's 16 times brighter than the Sun, there's nothing special about this star. It is located in our galaxy at a distance of about 2,000 light-years and is just one of the 400 billion stars in the Milky Way. According to NASA, the James Webb Space Telescope captured the star with a red filter to enhance its brightness. But the resulting image doesn't show the beauty of the cosmic depths that we're used to seeing in the photographs taken by Hubble. Still, it's, by far, the highest quality and resolution infrared image we've ever made in space. Lee Feinberg, the NASA engineer who was in charge of the development of James Webb's optical elements, believes the very first properly focused image was phenomenal. You not only see the star and the spikes from the diffraction of the star, but you see other stars in the field that are tightly focused, just like we expect, and all sorts of other interesting structures in the background, he told reporters. And that is yet another proof of how powerful the telescope is. But what are these structures in the background? They are distant stars and galaxies. And sometimes, it's the background that makes a photo famous. So what could scientists see behind this unremarkable star? One of the distant galaxies in the background is about 5 billion light-years away from us. But these are only the first and rather primitive observations of the new space observatory. So far, scientists have only checked how well the telescope can focus on a star. And yet, on the first try, we managed to see an object located 5 billion light-years from us. NASA has also released a new telescope selfie. The image was taken with an near-infrared camera. But instead of an image of the sky, it captures the uniformity of illumination of each of the 18 segments of the primary mirror. This way, a selfie shows the difference in the gaps between the segments. In the coming months, there will be more adjustments so that the segments become almost a single whole. In the meantime, the James Webb Telescope managed to pose beautifully against the background of the stars. It was captured by another space telescope, Gaia, which has been orbiting the same Lagrange point 2 as Webb, taking a full survey of the night sky every few months. And on February 18th this year, when the two spacecraft were at a distance of 1,000,000 kilometers 621,000 miles, the Gaia Observatory camera took a picture that shows a very faint speck of light, the James Webb Space Telescope. This was made possible due to a hyperreflective mirror shield that the Webb telescope is equipped with. Overall, the first focused image is a very, if not most, important stage in the preparation of the telescope. But real breakthroughs and scientific discoveries can be expected by mid-2022, when the telescope starts to take pictures at the maximum resolution and when all the instruments start collecting additional scientific data. But what will NASA's experts look for during the first year? James Webb's first targets will include small galaxies in our neighborhood, the remnants of exploded stars, and the oldest stars in the universe. The James Webb Telescope is, in fact, a time machine that would allow humanity to look 13.5 billion years back. According to modern concepts, the universe we currently observe formed 13.799 billion years ago. So, the difference is just some 300 million years. And that, compared to almost 13.8 billion years, is only 2%. Things that the telescope would be able to see could be the most interesting phenomena that ever happened, including the birth of the very first galaxies and the formation of our universe itself. We hope that in a couple of decades we will be able to create a telescope that will overcome the remaining 2%. If we succeed in doing so, we will not only see how galaxies and stars were born, but also what made it happen. As of now, scientists wish to learn how supermassive black holes at the center of galaxies formed. We have already figured out the way ordinary black holes appear, but it's still a mystery when it comes to supermassive black holes. One theory is that it's possible when many smaller black holes merge, but we have no clue about how the needed number of them could gather at one place at an early stage of the universe. The James Webb Telescope will also let astronomers compare the faintest and earliest galaxies with today's great spirals and ellipticals, helping us understand how galaxies come together over billions of years. We're all looking forward to what groundbreaking discoveries James Webb could make. So stay tuned to make sure you don't miss our new videos. So like and subscribe if you love the space.